Oh, my YouTube people. I am so sorry. You're exactly correct. We had a technical difficulty here, and I apologize. There it is. Well, I'm gonna have to just welcome everybody. I am sorry for the audio failure. I will try. I might be able to patch it in. We'll see what happens. We're locally recording this, so maybe we'll just use the local recording. Let's see. Who else is here? Audio's good now. Excellent. Let's see. Almost Machining is reporting 61 degrees Fahrenheit from Surprise, Arizona. Ash Reed, the premier Manchester, UK, minus 11 C, humidity 82%, light drizzle. Chris says, I'm really bad at reading lips. You are more to be envied than forgiven. Let's see. I think we did as well as we could do. So this is why you have a preamble. This is why you do a dry run before you hit the green button on your CNC machine. Paul Morley wisely reports from Dallas, Texas, 52 degrees Fahrenheit. And so who do we have in Discord? We have our guest, Machine Shop, Dan Gilbert. We have Unix Carbide, Paul Morley, Warren Jones, Justin P., Carl Tauber, Widgetworks, Proteum Machining, Almost Machining, Josh, Anthony P., Bill Olney, Thomas Hardy, and Robert Simpson. Welcome aboard, guys. So at least we got all your weather in the text. So that's all cool. Well, happy Sunday. It has been a absolutely glorious, sunny, magnificent day today. We're talking to you from Windham, New Hampshire, where it is 37 degrees and relative humidity 52%. The Manchester Airport reports winds are 310 at 11 knots, visibility 10 miles, clear, temperature 04, dew point -08, altimeter 2987. We knew you needed to know that. So today we have some business to conduct, and we have a guest, so we're going to get onto that as soon as possible. Welcome aboard, everybody. Let's see. I have a list. So last week, you might recall that we had a McMaster car giveaway announced. We're giving away this absolutely stunning cardboard box. I'm sure you would agree it's stunning. The most stunning part of it is the return address, which is McMaster car. This is the latest, the greatest McMaster car catalog, and we're giving it away today. So the rules were that you had to have your entry in before midnight last night. We only have 16 entries, so you guys have a pretty good chance of winning. And we're going to do that drawing right now. I'll remind you that during our program, if anybody in the Discord server has a question, and you want to make it a video question, you can raise your hand in Discord and you could come in and do a video question. Otherwise, if you have questions, you could put it into YouTube chat or Discord chat, and we will get them answered. Hey, Greenwood AG just checked in. Clear, 41 degrees, winds south-southeast at 6 miles an hour in south-central Idaho. Thank you. Now I want a potato and an onion. Let's see. So let's do it now. Are you guys ready to do it now? Is everybody prepared? Is everybody comfortably seated for this drawing? Okay, here I have the list, and I've taken all the entries and I've numbered them 1 through 16, and now we're going to go over to let's see, this screen right here, and we're going to hit this here button. But first, we're going to say I want 1 through 16. There we go. Can I get a drum roll? Can I get a drum roll, please? Anybody? Drum roll. Thank you very much. And click. I said click. And that's the wrong clicking in the wrong place. Here we go. Click. Number 12, you are the winner. Thank you. Josh got it. Josh got it. Let's see. So number 12. Oh, you're not going to believe this. I cannot believe it. Do you know who it is? Anybody want to guess? It's Evil's Devils. Evils. And he's not even here. Evils is in the EU. And he's in Ghent, Belgium. Do I have that right? Anybody in the peanut gallery? So Belgium. Yep. So the McMaster car catalog is going to Belgium because I don't know if I can. I don't know if I can show you that. Evil's Devils has won. Congratulations. I'm sure he'll be very upset because he's usually here. He's here like 90% of the time. Evils, it's yours. And I will take care of getting that out to you one way or the other. We'll figure it out. That's awesome. Okay. So that's our McMaster car catalog drawing. In 12 months, we'll do it all over again. So yesterday I had a really weird, actually it's more than yesterday, really weird issue, and I'm seeking the hive mind to help me solve this. Yeah, Unix Carbide is going to hand carry the McMaster car catalog to Belgium. That's our plan. I'm sitting in front of two Dell screens. It's the S33 something something QS. Okay, it's the curved screen. It's 32-inch 4K monitors. One of them started acting up, and the DP input, DisplayPort input, essentially was not functioning. So I scrambled around and decided I was just going to replace it. Bought a brand new copy, same exact model, dropped it in, plugged everything in, worked perfectly. What do you know? About 3 weeks later, that being approximately yesterday, same exact problem. The DisplayPort stopped working. So last night with Jared, my assistant IT guy, we managed to get it plumbed up into its HDMI port, and it's now usable. But I now have two Dell monitors that appear to have a dead DisplayPort. Paul correctly suggests cable. Cable has been tested for by substitution. No joy. Add-on video card. It is a GTX. What do they call it? 3060. It's an NVIDIA 3060. RTX 3060. Don't know what to make of this. DP is not the only connection option. The monitor does one DP and two HDMIs. The video card does three DPs and one HDMI. Yes, we confirmed the cable was not the issue by substitution. We used multiple different cables. Does it have an additional power socket on the card? I believe the answer is yes, and I believe it is employed. That's an interesting question, though. These are all good. I was hoping to find somebody, find a link somewhere that said, oh yeah, those monitors have a problem with the DP port, but I haven't found anything like that. It's not the end of the world. We're just going to switch to using these all in HDMI and keep marching on with life, but it kind of bugged me, and it wasted a lot of time. So the only other hint that you need to know if you're going to help me figure out what's happening here is in that second monitor, I used the monitor selection of inputs to change which computer that monitor was on between DP and HDMI. So it was switching between DP and HDMI by the buttons on the menu. No idea what's happening here. So we're functional, we're out of the woods, and we are not declaring an emergency. That is the story. So let's see. I think we covered the screen issue. So anything you could do to help. So as most of you might have gathered, my alma mater. Why don't you tell Dell to insert them where the sun don't shine? Well, I'm going to fire off an email to Dell and say, what for? Unix Carbide says DisplayPort, USB-C, HDMI. Nobody actually remembers how they were implemented now. I'm just worried that there's some bizarreness that switching between them is burning out a chip, and that would be like bad. And actually, Dell would want to know about that. Yeah, the thing about standards Unix is that there are so many of them to choose from. Anyhow, so my alma mater is MIT, and I was class of 1983, and my story is told on the magnificent Within Tolerance podcast, the link to which is in my links page, pfg.gg/links. So I won't dwell on that too much. But it has been a part of my history and in many, many, many ways. So a lot of tie-in to MIT. So through the magic of Instagram, I met this guy who was running a lab at MIT, and we started as Instagram friends. It was like, hey, back and forth a whole bunch, and we kept saying, "I'm going to come visit you. I'm going to come visit you. I'm going to come visit you. I'm going to come visit you." And I never got around to it. Finally, a couple of weeks ago, I got around to visiting, and I finally got to meet one Dan Gilbert, who is our guest today. And if you'll allow me, I'm going to bring in our guest. Let's see, where is he? There he is. Mr. Dan Gilbert. Dan, welcome aboard.
Thanks so much for having me.
Well, I wouldn't have it any other way. Whoops. There you are. So I was very, very pleased to get in there finally. And the circumstances under which we got to visit were that my son, Jared, had a tour, a school tour. He's a junior in high school, but he had a school tour of MIT, and I have to tell you that the tour was superficial at best. So after the tour, they took us from the Welcome Center, you know where that is, in Kendall Square, snaked our way through the campus, avoiding the good stuff, which really bugged me, and dumping us at the student center. And then I said, "Okay, Jared, now your tour starts." So I got on the doobly-doo, and I sent you a text, and we headed over to Building 35. And finally, for the first time, we got to meet. So let me give my introduction, and then you can give a more full introduction of yourself. But Dan is, his official title, I looked it up, official title on the MIT site is Technical Instructor. He's at the Laboratory for Mechanical Productivity. Mechanical Productivity? Manufacturing Productivity. And this is the shop. He runs the machine shop, which many students have their very first experience with a machine tool. And he is the East Coast. He is the East Coast version of Laney Machine Tech. Only better. And sorry, Laney. They have a very, very important job. So I'll tell one story, and I'll turn it over to you to tell me what I got wrong. And the story was that I was I think a sophomore-ish. I don't remember exactly. And I had this roommate who I will not mention because he's not worth it. And he said to me one day, "Hey, I got to go." He was a mechanical engineering student. He said, "I got to go do work on my project. Do you want to come?" And I'm like, I had just had a summer job where I interacted with some machinists at Bulova Systems and Instruments in Valley Stream, Long Island. And so I kind of knew about machining, and I saw stuff, and he said, "Do you want to come and I'll put you on a machine?" I'm like, "Yes." So he took me to this machine shop in Building 35, and he set me up. The first machine I touched was a lathe. I love lathe. And I made some chips on the lathe. And I'm like, oh my God, this is cool. And then after a while, he says, he comes back to check on me and make sure I have all my fingers. And he says, you want to try a Bridgeport? I'm like, yeah. So we walk 15, 20 feet away and I'm on a Bridgeport. I got a block of, unidentified material, and I start making chips on a Bridgeport. So that was it. I was totally and irrevocably hooked. But the thing that we finally figured out is that the room I was standing in, the shop I was standing in, is Dan's shop. Dan, welcome to PFG Live.
Thank you very much. And I gotta say, I think, Spencer, you definitely tried it a lot. And there were sometimes when I was out of the shop, or I think when you texted me or found me, which was good the way it happened. I was just running around and trying to get things ready, or we were teaching that intro basic course, which is 2.6, 2670, 2.60 to 670.
Yeah.
So it was good that you just came in and I get, behind, I think, on answering texts and things like that. But, and I'm definitely not, anywhere near Laney, So, but it's good. It's good. It's I'm working here in the LMP, or Laboratory for Manufacturing and Productivity. It's had a few different names. It's had a few different purposes. I think that at one point this approximately 5,000 square feet place was actually a consortium for researchers that also taught classes. So that was being run by Jung Hoon Chun, and he was making money, and so they were able to buy new machines for research and things like that, and then also teach with those. So that consortium since broken down. I think, maybe the way he describes it is that's it right there. So
there it is.
The way he describes it, professors come in and they start thinking that they want to have their own, if they're going to do a little bit of research on injection molding or something, they want to have their own injection molder. So they'll bring that into their lab, and then a few years later, it's not in use and it's not kept up. And a lot of the things in this lab have been brought here just because I've been wandering through, or I help a grad student and I see something in the corner, I'll say, oh, can I have that? And we've gotten the CMM from nuclear science, plasma fusion. And I was like, can I have that? And they're like, well, yeah, sure. And so paid for the rigging. Sure. Yeah. And it's the only CMM on campus, which is funny. So I think that it's a good introduction. I appreciate it. There's a lot of funny things, and I think we could talk for a long time about what MIT is and what all the people who are listening here today, I and even me before I came here, our impressions of what MIT would be or is are going to be very different maybe than what it actually is. And I think that, I'm always thinking a lot about what it is or what it should be and trying to understand that. And I don't know. So it's interesting.
Well, it is amazing how we've been talking about, you grabbing stuff that was headed for, being accessed. And it is pretty amazing. Now, I'll point out that the MIT used to have the instrumentation laboratory that's associated with it. The instrumentation laboratory spun out to become Draper Labs. And I have a piece of equipment that was accessed from the instrumentation laboratory, which we traced back by its tag. It was accessed to Brothers Machinery. It was sold to a guy. That guy sold. I told the story before, so I'm not going to tell it again. This is the Moore rotary table. That guy sold it to another guy. That guy needed to sell it because he was moving. That was steam machine sculpture scheme. Yeah. And I bought it. So now I consider myself the caretaker. But when I researched that tag, it turns out it was in the Apollo program. It was when they were developing the accelerometers, this piece of equipment was doing that. So then you sent me a picture. You posted this lathe, right? This Monarch, not Monarch. Is it Monarch? What's the big CNC?
Well, we've got a Mazak.
The Mazak, because recently you moved it in, right?
Yeah,
You
fairly
rigged
recently.
it in, and it was like, don't throw that out, give it to me. And so I got to see that when I visited you. So it's pretty cool, at least being able to keep your fingers on the pulse of all the equipment moving around and not let anything go to waste. While we're sitting here, I'll just point out that behind you is all sorts of stuff that you explained to me was rescued, right? That was going to head to the great melting pot in the sky. So that's pretty neat. MIT is for those of you that don't know, is considered the premier engineering university in the world. I get to say that, in the world. And so you're dealing with these kids. I'm also allowed to say that because of the gray hair. You're dealing with these kids that are pretty sharp, and they're in there. Some of them are in there because they're taking the course and it's on schedule, but some are in there because they're doing stuff that's pretty impressive, and you're helping them out. What's an example of like one of the projects that a kid was working on that was just like notable that you remember that you helped out?
Oh, well, one of them okay. So this lab, or I came from another place where there was only one machine shop on campus, and it seemed like the model there where we teach classes, but we also help students, undergrads, with their projects, and then researchers, and there was about 4 of us maybe as machinists, and that was learning. You could almost call that my apprenticeship. And so when I came here, I kind of saw that when I was hired here, because I was at my desk at the previous place, Clarkson, and I was getting interested in machine design, and I thought that was the coolest thing. I think I was inspired by the DMG Mori videos where they do the exploded views and you can see the castings, so I started reading about precision machine design and found Alex Slocum's book, and then came to MIT and started this shop. When I first came here, it was coming off of a different person who didn't want to help any researchers. So the school had actually taken some of that shop space away. They had recently renovated a space behind me, the room behind me, to be a computer lab. And so they took that away and made that a student-run makerspace. But then when I came, there was a bunch of us that were new, and we wanted to help researchers. So it was weird because the shop started being set up only if the classes that we taught only used 1/8-inch drills. That's all we had, and we didn't have drill sets, you know. So it was very weird, and so we've come a long way in terms of helping and being open. We'd like to help more people. It's just been so busy. There's really only 2 of us here. So yeah, but I gotta say, Bridge Bouchon, actually, he's now at ASML, and just awesome stories. So he'll come back and be able to tell things, and just talking about the level of cleanness of these places. But when he was here doing his PhD just a year, maybe 2 ago, he was working on electrostatic levitation of wafers, because once they're coated, they could be levitated and moved around and even flexed in the air. So he was working on that, and this is when you say there's people that are just incredible. He wanted to use the Haas milling machine, and so I gave him a little bit of help, but I think he knew exactly what he was doing. It wasn't long, and he was just off on his own running those, and he was able to do that because I guess the silicon chips that they're making, normally if it's like an air gripper, or if you lay it down on a piece of aluminum and you're basically letting it flex a tiny amount, probably less than we would even really see. But Bridge was explaining to me that the amount that flexes actually creates tiny chips and particles from the silicone, which is, again, dirt and dust and particles and contamination. So they wanted to get away from that. But I don't know. That was pretty cool. Yeah.
Wow. So, so if a student comes in to mechanical engineering and they want to learn, for some reason they want to start learning how to machine stuff because they have a project. Is it in fact, is that your shop, that's the first place they're going to go?
This has also been an interesting thing. I think 5 or 10 years ago, there weren't many places where people could work on things. So now there's been all these little shops popping up all over the place. There's an odd amount, I'll say, at MIT. There's an ability for shop managers to get lazy and to be able to say no to projects in a large way, whether it's rules that they set up or what. I think so we're trying to lower those barriers as much as we're able while we're still setting up for classes and things like that. If they want if they're part of a class and they're taking basic shop, which is only a 2-day course,
Mm-hmm.
then they'll come to us. They'll come to Papalardo, which is a huge space, but they're not open for researchers or really for personal projects. Great guy, great group of guys over there. Huge space, like something like 11,000 square feet. So we just taught over the IAP, which I forget what it activities.
Session activities period, I think.
Okay.
So
we just taught
at MIT. IAP is the thing that happens between semesters, and they treat it as a special time where they have interesting courses and fun things. And anyway, it's called, of course, because it's MIT, it's called IAP, and it generally it's January, right? It's the month of January.
Yeah. So, and then there's one other guy, Pierce Hayward, in Building 1, who teaches 2670 throughout the semester. But if somebody came in and they wanted to do something, I don't want it to be that they have to wait for a class, because it seems like there's enough of these barriers that like it stops the students from doing projects. So especially with researchers, this happens more often, that they'll come in and they'll need to do something. So I'll set them up and make sure they're being safe, but then they just go to use the lathe, right? In the summertime, if it's your ops, they'll just come in and what are we going to do? Like say, no, you got to take this class first. And then we're going to offer
Let me explain that.
Yeah.
I'll be the acronym translator. Okay. So UROP is Undergraduate Research Opportunities Program. So that's, which I participated in. I was in the balloon lab, the X-ray balloon lab in electrical engineering. And that's where students will get a job on a research team, paying job, and they make stuff and they build stuff and they assist with the research. So that's called a UROP. So now everybody's up to date on UROP.
Yeah. Sorry. So that's a great opportunity for people. And so yeah, this is a shop where people can come in. I think sometimes I gotta apologize that like if I ever say like I'm just too busy right now, it's because I'm trying to fix some machine or get ready for classes or something like that. But hopefully we can have more ability to help everyone. I'd like people to get more into it. I think there's a lack of very basic classes maybe at MIT. They always jump into something. It's good. There's a lot of making classes within mechanical engineering. Yeah.
But if you had a student come to you and say, look, I'm doing this project, I don't know anything, and I'm not in your class, you're going to help them anyway, right?
Oh, yeah, absolutely, if we can. I think and when we teach the 2670, the basic shop, we always say, like, absolutely, one of the things that I've been, my flight attendant talk is, look through all the drawers, kind of memorize what's in the drawers so that you can, if it's like bolts and nuts you need or whatever, just come and get them and take them. And then people bring them back, or bring back like, if you order from McMaster and you needed 10 and the box had 50. So that works out. I actually don't order nuts and bolts or anything for those drawers out there. There's kind of a place where people come and get them. We'd help them out. People get so busy during the semester that I think they don't have time for personal projects anymore. So the semester makes, and another thing I think at MIT, they try to do a lot of things. And so unless there's something making them do it, maybe they don't always do it. But we'll see projects. There's somebody trying to remake a different way of doing the Songbay's cheetah robot. They wanted to flip how the motors were for each of the joints to to be able to use like off the shelf motors. Chris has been in a lot and doing a lot of CNC work. So, which is good. It's
So
great.
when you say that the cheetah robot, this is the same or the same roots as the robot we see from Boston Dynamics. So
Yeah.
if you folks have seen a yellow four-legged robot dancing around and jumping and stuff, that robot actually had its genesis at MIT, and that whole program is still its own thing, right? They're building these robots, and this was a project that somebody was trying to improve the design or change the design to use easier to get parts. Am I reading that right?
Yeah. Yeah. And then we had a bunch of people come through and do a lot of cool projects too. There was a very someone who really had a whole story arc, coming in being nervous about things to now doing tons of machining at a different place. And I was thinking, so let's see, she actually started doing jewelry, which was wildly interesting and popular for a lot of people, which maybe the flashlight, which is 2670 to make a flashlight. She also offered a ring or jewelry class, and people were very much interested in that. And now actually she's spun out and she's created a stainless steel chain called the Slater chain, and she's selling them just now. She's opening these. And so she ordered those from China. But now she's actually working for a different company where she's set up their lathes, their mills, and just writing manuals. Oh, which is another interesting thing. The manuals, because we can't, yeah, I'm getting the words, but Papalardo has a large staff of people ready to help everyone who wants to do anything in their classes. The LMP, unfortunately, or maybe fortunately, there's a lot more self-learning. And I think that's where it's hard for students, because they have to just go through and try to do things on their own the first time. So we have been writing user manuals as well.
Mm-hmm. Yeah, you showed me interesting manuals. Yep. So this student you were talking about, she came in with no knowledge of machine tools, machining, or anything, and then not only did she learn the art, she started making art and developed a whole thing, and now she's off teaching. Right? She's teaching.
Yeah.
That's awesome.
Well, she's actually at an engineering company, so she's doing engineering every day and doing all that stuff. But she has also set up their prototyping lab. So it's kind of cool. It is cool. It would be nice if we could see more of that happening. You know what I mean? It's like, I don't know if we reach enough of the students or get them involved enough. Of course, that's what we're saying, right? I'm sure that the engineering department, well, they've got to also learn all these engineering things, but
yeah, wow. I could tell you that there's a lot of learning that goes on that has absolutely nothing to do with coursework, because I observed it. So
that's also a good point.
I will have to send you a picture. I don't have a picture handy of this, but I may or may not have been involved in a hack where we built a 33-foot tall left-handed wood screw and erected it on the Great Dome, and the base of which was a universal joint that the same person that got me started in machining made, and it was probably made in your lab. Hey, when I visited you, you showed us a picture which I used in the thumbnail, and the picture was taken. We were not really sure, but if we had a guess, it's got to be the 50s, right?
Yeah.
So what's the early? I mean, you've identified that space as being what it is back to at least the 50s and maybe earlier. In fact, a fun thing that you showed me was in that picture, and if you guys go back, it may be hard, but right under the letter F, let me turn that back on for you again. Right under the letter F in PFG is a weird little drill press, and I believe that little weird little drill press is also still active in the lab in the shop.
Absolutely. It's actually so one of the main classes we teach is 2.008, or the yo-yo class, as I think as the students know
Yeah.
it as. Yeah.
Yeah,
So
talk about that class.
yeah.
That's awesome.
So we're getting ready to do that this semester. The enrollment is low, oddly enough. I think that 2671, the instrumentation class, is a lot. So I'm finding out from other students. They said, "Yo, Dan, Chris told me you're asking why 288 has little students. I heard it's because a lot of people are taking 2671. A lot of people like the flipped classroom, which is the other semester. So I've been asking around because right now it's at 22, which is kind of scary, but we'll have enough to do. So 288, they design yo-yos in teams of anywhere from 4 to 7. Ideal is 5 to 6. They machine the molds out of aluminum, and we put those molds on mud frames, which we use as the main frame where they're bolted on, the modular unit die. I think a lot of people would buy these mud frames and then machine their molds onto the actual mud frame, but we've made a real frame that they can drop in and out, and they get like a 4 inch by 4 inch block, 1.5 inch, and they make core and cavity out of those molds. And then they'll injection mold and then see that product, and basically they have to do a press fit on this yo-yo. So it allows them a lot of iteration. It's really fun. I think it's the only iterative class. And this lab really focuses on manufacturing, whereas other labs like Papalardo will mainly focus on design. And there's a large split in the department, actually. So there are people, unfortunately, there's people who call themselves design professors and manufacturing. And the split is very surprising as well. I think that something I'm used to, but it's like, I guess not everyone realizes this. So, I don't know. I think those could come back together and be more of a one thing, because the students will think that when they're doing the yo-yo class, they're thinking, I'm not doing design. I'm not doing design engineering. And then when they're over doing design, in other classes, they might not really see as much of the manufacturing or even prototyping. I think
Hmm.
so. Yeah, yeah.
So
It'll also be.
what order should they learn these things in? Should they learn design before manufacturing or manufacturing before design? I have an opinion.
I don't know. And I think that's something that would take me a while to think about, and I'd want a lot of input from people who are much wiser than me.
Yeah.
But I think the main thing is that it's hard for students here because there's not this step by step by step. There's so many opportunities and there's so much funding to do all the latest things that there's it within MIT. We need to, like, in my opinion, maybe calm down a little bit and be able to create a pathway for students, because
Yeah.
I think that they're not realizing necessarily all of these things. There's like got to be 12 at least water jets on campus, and no, there might be one plasma cutter now. So it's like they'll be seniors and they don't know what plasma cutting is. They don't know that it's available to them. They don't realize these things. There's all these kinds of things. Yeah, if there was a pathway or if there's more of a basic shop, I think a lot of the instructors wish that 2670 was like a full semester thing where it's just basic shop. And we slow down and there's simpler things, and I don't
Hmm.
know.
Let's talk more about your yo-yo course, because I got to see, when I was visiting you, I got to see examples of some of the molds that were made. And what was really cool was seeing your your display cases of finished yo-yos, right? So proudly displayed it has to be what, 100 of them up on the wall.
Yeah.
Um, and it was really impressive. And I got to see some of the injection molding output, which was really neat. Unix Carbide, it says chicken egg, referring to our, which comes first, design or manufacturing. It's a chicken and egg problem. Robert Simpson says manufacture before design, so they have an idea of what the constraints of making a tangible object is. Speaking from experience, starting with design and then learning, it can't be made the hard, expensive way. And Robert is I'm in violent agreement. I think learning about manufacturing makes you a better designer. And maybe the other way around. I don't know, but I agree with that order. So talk more about you have two injection molding machines in your shop, right? Um, I'm not familiar enough with injection molding machines. Do they have a size that you describe them by?
I'm not super familiar either. There's one that has two bars, and we have to put a nut and a bolt on the mud frame to keep it from going like this. And then there's a four bar one. There's an Arberg and a Boy. The drill press is our high speed drill press, maybe 9,000 RPM or something, and
Mm-hmm.
we put a small tiny drill just lives in there, and that's for drilling out vacuum holes on Formlabs printed dies for thermoforming. So what they'll do is they'll design a die and print it, or have the LAs print it, just so that the LAs don't dribble the resin all over the classroom. We found that if it's a free for all where they're printing, the resin droplets just are everywhere. So that's another part of this yo-yo. They have to have two injection molded. It used to be three injection molded parts, but
Mm-hmm.
now I've lowered it down to two because we want to simplify and we want to focus or make room for students to start to understand that this is not really about yo-yos. It's ideally a class about learning very fundamental things like designing for manufacturing, or really just problem solving, troubleshooting if we can get there. I think that it's hard. And then, the other thing that's it. So we got a couple injection molding machines, a couple Haas mills, which when I got here as well, they were using track 3-axis mills and doing all the tool changes by hand, and some air oil mist, and the floors would be slippery. And I'm surprised no one ever slipped, fell, and sued the school. But the Haas are really good, in my opinion, for this rapid learning, because we're saying that there might be somebody that comes into MIT not knowing how to do stuff. Sure. I think the reality of it is that there will be juniors and seniors who come into 2008 never having really touched much in terms of making, and we're bringing them through CAD, CAM. We just assume that they know CAD, which is not, the students would love a CAD class. And there's probably like students going off if they're listening to this or something, but they love a CAD class. We teach them CAM and they kind of learn it. And then they're in a number of days or hours, they're really learning the Haas milling machines. And then they're going on, right? And so I will do a little bit. I'll show them how to use the machine. And I've got it down to a 27-minute video what's been recorded. But I'll do that. And then I'll say, all right, next student up. They'll be pressing the buttons. And then I'll say, okay, the student after them, the first student's going to show them what buttons to press, and we learn it like this, kind of
That's excellent.
chained. But it's interesting because I think that when you're saying that they should learn manufacturing first and then they learn this other stuff, I agree. But I think that now we're starting to force talking about students who have never ever done sometimes any making of things, right?
Mm-hmm.
And I mean, they're great, they're awesome, they're geniuses, but sometimes they've never used a crescent wrench, and that's the truth, right?
Mm-hmm.
So when we say manufacture, the professors want to start teaching about design for manufacturing, mass manufacturing, producing things at scale so that the production can reduce the costs. That's what they're talking about in terms of manufacturing. When somebody from this chat or the Instagram world of machinists thinks they should learn these things first, yes, I agree. They should learn how to use a mill and lathe, not necessarily laser cutters and 3D printers, because those are too much of push button things, right?
Mm-hmm.
People will come in and they'll press the go button on the Haas, and then you'll across the shop and they come talking to you. And you're like, wait a minute, aren't you running? And they have no idea. I think there's a lot less of operating machines and there's just letting the machine run. So in my opinion, we need to offer more basics where they're actually focusing on these things, where they're learning how to use mills and lathes and punches and sheet forming and things like that, hammering.
Mm-hmm.
Yeah, before we go into then manufacturing, and then we can do design and all of these things. But there's a lot of people that would have very different opinions on, well, you've got to learn how to have design first before there's a lot.
So again, a little acronymization. 2008. Let's just break this down for people. At MIT, you got courses. So mechanical engineering is a course. That's course 2. So 2 dot, and then the rest is the course number. So you're involved with how many different courses right now?
Oh boy. We're involved. We do 2008 every
Yep.
semester. That's an awesome class. That's actually Design for Manufacturing Part 2. Design for Manufacturing Part 1, where they really lean on the design part, is taught in Papalardo. And they're introducing students to basic tools and things like that. It was interesting and kind of funny because it was like, that's where the students are helped when they first do a bandsaw cut. But there is an interesting thing where they can, I gotta be careful. If Danny runs the Papalardo lab,
Yeah.
great guy, and I wonder,
And he's welcome to come on with a rebuttal.
Yeah, that's true. I don't know if he'll see this, but it's sometimes when I've been asking him for advice, I get, and I want to work on this. I need to not ask the students, what do you think? They really don't like this. So I ask him a lot, and he thinks it's good. And I think I wonder, because what happens is when they're learning over there, they've actually told me that our teaching styles, where we're asking them, what do you think? Or we say, well, give it a shot, try to figure it out at first without us, and then we'll come right back and we'll help you. They don't like this. They say, well, I had a student actually stop and be shocked and say, well, this isn't what I thought it was going to be. And what do you mean? And they say, well, in Papalardo, like, they'll be right there. They'll show you how to use the machine again, whereas this, it's more branch out, the way I first describe it in 2670 is, what if you had this lathe and it was in your garage, or it was like, you're not allowed to use it, what would you be doing? How would you try and figure it out on your own without breaking it? So we teach 2670, which is basic shop. It's not nearly long enough, in my opinion. We teach 2.008, which is Design for Manufacturing 2. We teach 2.72, which is Marty Culpepper, and where he teaches them or helps them make a little benchtop lathe as a team. He's doing all the things like kinematic coupling. He is one of Alex Slocum's students, and John Hart, the department head, is one of Alex Slocum's students. Amos Winter is one of, I think, maybe Marty's students. There's like a whole chain of these people. Amos Winter teaches 2007. Mm-hmm. So we teach 272, the lathes class, and that's good. That's kinematic couplings, flexures, a lot of water jet cutting. We also teach 2810, the graduate version of 2008, to help them get ready for quals. We teach, we help out in the beginning with 2830, which is a statistical measurement and process control. So they make a bunch of parts on all these different machines, and then they take the parts and they measure them, and then we don't really see them for the rest of the semester. There's probably more that I'm really not thinking of right now, but yeah.
So if some of you who are listening to this are saying, that's a lot of numbers, all I have to say to you is, welcome to MIT. It's a lot of numbers. When I was in there, you were measuring, actually your was it Wade? Your assistant there was, he was measuring a bunch of parts with a laser, with a what do you call those arms? Faro arms, and a laser sensor and stuff. Was that part of which course was that for?
So that is, I think there's a lot of things where people come in and they think MIT has this, right? And now there's a nano building, and that's good because on Sunday I stopped at the Stata loading dock when I drove here in the morning, and I saw these things, trash that MIT is throwing out, thousands of dollars worth of stuff, right? The 10-foot optical table that we got at the front is free because someone was throwing it out. I stop in and I see these things, and I'm like, those are going to be perfect table legs. Let me go put my car in the loading dock of our building. I'll walk back down. By the time I'm walking back down, Eric Calvert, who's the guy who organizes all this stuff, he's like, he loading them on a truck. I say, hey, I'd like a couple. He helps me wheel a couple over. Now there's a table. There's 2 more tables that I've made out of those things. That'll be ready for Monday. It's just, oh, sorry, where were we? I got to see, he also said, oh, I'm cleaning out the old Nano building. You want to come and see what they have for stuff? I take a quick tour through all the floors of the old Nano building. So there's a lot of things that people might say, yeah.
Can I just interject? You say old Nano building. It's not that old. Because at some point there was no Nano building. And by the way, for everybody, Nano building does not mean an extremely small building. Okay, this is nanotechnology where they're doing work on things like integrated circuit structures or MEMS, tiny structures, tiny structures. That's what the nano building is about. So, yeah. Sorry.
So I just think no, it's good. That's it. There's a lot of things at MIT, or there aren't a lot of things that people would say, oh, I bet MIT has that. Or I think a good analogy, now that I'm here, I think to kind of like dream big, I think it would be, what would we imagine that the CIA has? And we might draw some huge list, and we get there and they're like, no, that's not. So there's one metal 3D printer, I think, on campus, and it's a small EOS thing, and it's new, and it's recent. So John Hart, the department head, is really trying to he's gotten money for this center, and he's trying to create it where people can do 3D scanning of an object, print that object, whether it's polymer or metal, and then machine those parts that they've printed. So that arm is the first piece in, well, there's one of the pieces in this new center. So it actually doesn't have any classes yet. Yeah.
So it sounds like there's a bunch of activity on the campus that's splintered. I wonder if there's a way to take all of those, the common interest here, which is basically mechanical tools shops, and get, bringing them all together and just say, let's talk and make sure we're all singing off the same page of music.
I think Marty Culpepper tried doing that in the Project Manus. They made a website. They tried to link, at least create a map of all the machine shops.
I think I saw that. I think I saw that.
Yeah. So it's had, I don't know, some success, limited success. It's really hard, and I don't know why, to get all these shops. One of the things that they were trying to do was let's make a basic shop class that the students take this shop class and they're good across all the shops. Like, it introduces them to all the shops. That doesn't exist anymore. It's that you'll have one shop say, well, we got to really worry about safety here, so we don't know what kind of training you got over in such and such shop, so you're going to have to sign up next Tuesday on the third moon to take our shop safety class. And yeah, so there you go. And then, but it's an odd world. It's a thing, it's like, if you know the shop like manager and they like you can, it's fractured. It's tough. And I need to think about this in a positive way, and work on it in little ways, but I don't know.
Unix Carbide asks, Dan, you seem to be the person to know where and when MIT trash is put out for various departments. Is there a city/garbage schedule posted somewhere? No.
No. Okay, so when I first got here, I learned about this because I had to ask, there's reuse, which is the email system where people post that they're getting rid of something. There's reuse for the hallways, where if you put something in a hallway and you have to tag it not for reuse, or someone might take it. If you do put reuse, people are going to take it, strip it apart right there. It's like, I grew up on a dairy farm, and if a hawk caught a dove or a pigeon, all you'd find is the feathers splayed out, and the chicken, the breast would be stripped clean, right? So that's, if something's there that is good, that's what you'll find.
Do you hear the same sounds when that happens?
You don't hear it at all. These things happen. These things happen very quickly. So, the table that I got for the front room, I heard through the grapevine, maybe a student said something, because I wasn't paying attention. I don't pay attention to the email. This building is physics. The building was having a clean out. I heard it from another student, so I wander over. I'm a couple hours late. All the drawers, there had to be 15 to 20 students going through all the different drawers, grabbing lenses, grabbing tubes, grabbing things like that. And so I knew there wasn't going to be any time or space for me to grab anything. But I wandered in and I said the ridiculous question. I said, "What about these tables?" Just asking like a ridiculous, and they're like, "Well, we're actually getting rid of both of them." I said, "Okay, how much is it going to be to rig it out?" And they said, "Well, we're rigging it out anyway. So where do you want it?" And I was like, "This is awesome."
That's
so they rigged
fantastic.
It in. Yeah. So there's those things. The school formerly EHS tried to set up a reuse page. It doesn't get any use. The students, there are some like scavengers on the outskirts, we'll say, and they set up their own programs to scrape for these emails, or if that's what you call it. So they figure out earlier than anyone else if something, they can check them earlier than anyone else to see. And you think it's funny, but it's like the school throws away $1,000 things. Like a lab is being cleaned out, throw the stuff away, right? This lab was a physics lab. It's now a thing. So what I do is, as often as I can have the energy to, when I'm driving home or biking home, or I pull into Stata loading dock and I just check and I go through it. And it's funny because it's like the last time, before last time I checked, and there was the usual scavengers down there, and I have the good conversation with them, great people. I say, "Hey, I need to post a whiteboard." I said, "Anytime you need to make anything, come over to LMP." And they, "Oh, LMP, what's that?" Okay. So now I said, "You know what I've really been looking for is a larger ultrasonic cleaner." So I'm like, they're like, "Oh yeah, there usually some come." I leave the shop at night, 7 or 8 the other night, and as I'm walking out, there's someone sitting in a couple chairs that I put out there, and there's an ultrasonic cleaner on top of the cubbies that I put there. And he's like, "Oh, I was just about to email you. I found one." I'm like, "This is amazing." It's like,
it's the ultimate efficiency.
Yeah.
Yeah. There's nothing like it. I was showing Jared as I'm giving him the tour, right? I'm giving him now that the tour is done, here's the rest of the tour. And I said, "You see that building? You probably know which one I'm going to talk about." I said, "You see those dewars sitting outside the building? If you ever needed liquid nitrogen in the middle of the night, you bring your little dewar down there, find a tank and help yourself to liquid nitrogen and go about your business." And we had these, you kind of knew where stuff was. So I'm completely unsurprised that this happened. So I told you before about Brothers Machinery, which still exists, I think, but not in the same form. And they had been contracted to clean out a storage space at Draper. So I'm in my young, just infected with the virus of machine shop phase. So this is like 81-ish, 82-ish, 83-ish. I'm not exactly sure when. But I discover Brothers Machinery. So I go to Brothers Machinery and I walk in the front door, and there before me sits a literally brand new Hardinge HLVH. And not only was it brand new, not a scratch, not a chip on it. I talked to the guy, I said, whoa, where'd this come from? He said, "We just pulled this out of Draper. They bought it for a project. The project got canceled, and it just kept getting pushed back in the storeroom. Finally, we cleaned out the storeroom." He said, "All we did is we had to put fresh grease in it because the grease had dried up." And I said, "How much?" And he said, $15,000. And that's when $15,000 was probably, I don't know, $50,000. I'm not sure, today. Boy, howdy, if I was able to afford that back then, I would. But that happens a lot, with this equipment. It's like, okay, project's done. What do you do? So being able to have this network of people and sensors out there finding this stuff. So when I was at your shop, you showed me a bunch of your your shop organization tools. You were organizing these cabinets that were the same at each milling station, cabinets that were the same at each lathe station. Talk a little bit about what you're doing there and how it helps the students.
Yeah. So I I don't know. In conjunction, like a lot of other people, a lot of the students, the LAs, the lab assistants, they've done amazing work on this project. Really, I don't know. We should name it or something, and write. We should write down all the improvements. But it's basically making things more user friendly, right? And easier. And so, what I tried to do just to make things easier, one of the things is made all the top drawers on all the mills, manual mills, CNC mills, and lathes. We've done, I forget, all the same, and we used this 1-inch foam from McMaster, and then cut it out on the laser cutter and printed on the tool picture on top of it. So that makes it easier, and I just cut the foam at the different height so like all the wrenches the foam for all of the wrenches in all of these top drawers. I just cut it on the bandsaw it's all very rough right now. It's not nearly as good as that Kaizen company.
Yeah.
Um, and then it's like 1,000 different things. That we've got a general tools bench, and it's like watching the users come in and maybe they can't reach that thing. So we're gonna lower that one, move these over. They never use that thing. So we get rid of that or something. We move things around, make it so that people can have better use. And I was just working this weekend on the Hosses. I want to put the tool chest on the left-hand side. So those Hoss shelves that you get and you can attach to the front of the Hoss. I know it's crazy, but like I feel like the next Hoss, if we get another Hoss, hopefully, they're gonna wheel it in, and then I'm gonna go to town on it. They're gonna be like, "What are you doing? You're totally." So I take the back cover off and I put a little piece of tape over the microphone for the beeper because it's too loud. It's going to be annoying for us. It's going to be annoying for the students. I lock out the touch screen. I think there's enough going on that there don't need to be. And then I turn the keys to the right things because sometimes, and again, it's a question that they say, "Hey, Dan, it's not working. Come up to us." And then I go out and I see that, when they were holding the side of the controller, they bumped the key. And now it's not in edit mode anymore. So we put tape over those.
Yep.
The Haas door on the VF2, I think it would crush someone's arm. So I've also taped over that. I recently undid the hosed set thing because since I moved the cabinet, I moved it to the other side, and I want to be able to put a computer there so that the students, when they're using Fusion, we use Fusion because it uses Macs and PCs. And it does a nice job of integrating CAD and CAM. So I want to have a computer there so that they can use their computer or have it up, have the cam that they're running up. Because what they'll do is they'll get the cam from another student on their team who made it, and then they'll say, you'll walk up and they'll just be running it without any kind of realization of what they're trying to run. Mm-hmm. So I took the hoses off of that, and the hose for the coolant is just underneath the machine. I'll figure out how I'm going to hook that to the other side. Just a lot of, I don't know, stuff like that.
I think you need somebody from Haas to come visit and basically say, look, these are our issues. And maybe they could learn something.
Yeah. I don't know. It would be nice.
But is it the Haas mini mill? I think that's what I saw.
We've got a Haas VFOE, which is nice because then we can let researchers use that for whatever. And then a Haas VF2SS. And then a Mini Mill 2. And the important thing is that we have a tool library. It's actually these right here. So we have this tool library that they can just download from Fusion, and then they go to town. So we're setting up things like the offsets for them for these molds. We have a fixture there. And then this created before me by some very smart people. And we have tool libraries so that we have to have at least a 15 tool library. The probing is really nice. Just for a lot of this stuff makes it faster for us to answer questions, to get them going, so that really what we're doing is we're taking apart all of what the Instagram machinist community, we're taking little bits of this that they get to use to do this whole process so that we can focus on what it is that they're learning. So yeah, there's tons of things like the manual mills. We've got bridge ports with 2-axis track controllers or but just tons of little tiny edits that probably no one really will. I don't know. I think that the students will, they might not realize it, but it's making it better. I hope,
And my observation from my visit was that you're going around with the mindset of how can I make this better for the student? How could I make this a better experience? And you told me a story, which I thought was fantastic, which was, I think it was an example. You said, for example, if a student picked up a gauge pin and used it in a way that scratched the gauge pin, I would rather they do that and then explain to them what happened and say, that's okay. That's fine. No problem. Throw out the gauge pin, put another $5 gauge pin in and keep moving, rather than the alternative, which I think many of us have seen, which is all these tools, don't touch them. Right. And you specifically told me that you don't want a student to experience the don't touch these, experience, the getting scared off of touching some stuff. So talk a little bit about that, because I think that was a really super good attitude about how to teach.
Yeah, I think, and I gotta preface this that I'm human. I get frustrated. I try to do too much. I know that I learned a big lesson for me was when I was working in the summertime. I realized that if I come into this shop with an agenda of things that I'm going to try and get done, I'll get frustrated, right? There's so many interruptions, and that's fine. I just needed to learn that I need to come into this. So when I first started here as well, there were people that they were so scared of like losing the machines or having crashes that they'd run up, if a student crashed the machine and then the tool holder, what we see happen, students don't have a sense of like, that's a bad noise, or like, I mean, I grew up on a farm, and for this community, it's pretty normal, right? If I was crashing a machine and there was a low frequency vibration noise, I'm finding myself, I need to say, whoa, Dan, slow down. The student didn't realize that they were crashing the machine because the coolant was covering it or whatever, right? But now I need to realize, how do I teach them what a crash is and what to look for? And then the most important thing that you're saying is, we used to have somebody that would run up and slap the e-stop and say, whoa, whoa, whoa. And immediately the students will not go back to that instructor. And so I need to always be learning personally how to be kinder and remember what it's like if I were learning something. So that's something I always need to be working on. And so we need to teach in a way where it's okay to make these mistakes. So recently I was trying more and more over the IAP. I'm teaching 2670, and I thought to myself, not only do I need to tell them that it's okay to crash things or do things like this or do things to the bandsaw or the lathes, maybe the lathes, changing gears on these, we've got sharp 1340 lathes. They grind the gears sometimes. And I thought, not only do I need to say that it's okay to grind these gears, I need to probably do it and show them that this is okay. Show them me doing it too. So now I'm working that into my curriculum almost. So we do see so much of this, and some of it's the students, but I also don't want to take that cop out. They're very scared of the machines. They're scared of breaking things, looking foolish in front of their friends. If the more we can get rid of all that, then we can start building up their confidence and things like that. So it's interesting. I think it's a different world than a lot of machinists would maybe think about. It's like, it's not, you can't be that. The way that most machinists have had their apprenticeships, it wouldn't work here, right?
I've seen, this is also the age range where either they just learned how to drive or they don't want to learn how to drive, right? It's like that. Isn't it the same thing, right?
It's crazy. Yeah.
I know young people who are essentially scared of driving. They're not going to do it. And then I know other young people that are like, in fact, I just interviewed one. I don't know if you know this. I'm an educational counselor, a volunteer educational counselor for MIT. So I do the in my geographical area, I do interviews for admissions, and I met this one student who, at the earliest possible age, she's like, oh, I got to learn how to drive because I have to go do all these things. So she's like, boom, in there, like in N weeks, learns how to drive, gets her license, and then she's on to the next. I'm like, oh, whoa, hey, whoa, that's amazing. And then I know other students who are like, yeah, I don't want to drive. I'm nervous about it. So I can imagine that in that same age range in the shop, you're going to get the same thing. You're going to like, whoa, big scary machine. Either I'm on it or I'm scared.
Yeah. Yeah, I think that's true. And then I think it's a lot of me needing to figure out how to do this stuff. And so I hope the students are patient with me and see that I'm trying to do, but I think that you can't ask people what do you think? If there's some thing, I need to be able to communicate with the students differently, because if I and it's so it's a little bit, so we'll do introduction, we'll do demos of the machines, they'll be using them. And this is something that we were talking about earlier, but like, let's pretend that there's a short shot, right? There's the mold doesn't fill completely, and if they come get me and they say, what, there's something wrong, and what my stages, when I first got here, I'd say, what do you think it is? What do you think? And then now I've been dialing that knob back, even though even last semester they're saying it's too much. So now I try to think, now while I'm walking with them to the machine, I'll try to get them to define the problem. So they define the problem. And now when we're at the machine, I find that I can't ask them again, what do you think? I need to think, I need to break the problem down. I need to narrate how I would go about diagnosing what's wrong. And I think that's what I'm going to work on this semester, is not ever asking them, what do you think? Because that's too much. I need to help them define the problem and then break it down and narrate how I would go about solving this. There's a hopper of plastic pellets. There's the screw. We can check if the pellets are getting through the hopper. We can check if the pellets are getting through the screw. We can check if the plastic is going to be able to get into the mold. Maybe you forgot to make a runner and gate. So it's these kinds of things I need to be finding out how to make them all quieter. I've taken all of the hydraulic tool in, tool out for the R8 spindles. I've taken those all off. I went with the mock tooling system, where you push back a spring and there's actually like a pull stud on the back of all the tools. Much quieter. I'm just trying to make the atmosphere much quieter. I got a decibel meter, trying to make it quieter, more friendly. And then maybe someday I can get to a place where we can have a conversation about, I don't know, how do you think this might, maybe I need to just use the words like imagine. Yeah.
I like that you're teaching the logic chain, as opposed to, because if you say to a student, what do you think? They don't know. Right. So you're teaching the logic chain, and then you're saying, okay, go down this logic chain. And now it's like, okay, that makes sense to me. And you're showing them the path. They still have to walk the path, but you're showing them the path.
I hope so.
We have some questions coming in. Unix Carbide says, question from somebody working alone. Can you speak to the time cost investment of shadow drawer layouts and what it provides for collaborative / student environments? I.e., actually he says e.g., different. You shadow a box a lot. What's the time cost sink? Do you have any, this is most important, tip to share? Go.
Yeah, so along with the shadow boxing, I think there's something that I've been lucky to be able to develop. So it's watching the user from a distance, like a Safari, and seeing what are they actually doing? What are they having trouble with? And being honest. I think this is another thing that I've worked with enough people now, and I've seen them younger than me, older than me. It's very, very, very hard to do. To be honest about your design and what is working and what is not. There's some kind of magic there that I think a lot of people can't do this. They can't look back and say, oh, the user's having trouble with that. I'm not going to blame the user. I'm not going to go up in a huff and say, you should do it this way. Like, put the hammer back on the hook. It's like, well, your hook obviously is too hard to put the hammer back in there. So time and cost investment, drawer layouts. Another thing for the users, I think it's easier because then they can see where to put the tools back, and that's fine. I've also started thinking, with Allen wrenches, I got the Bond Hoos for metric and standard, and I just buy packs of those. And so it's no big deal. I just walk around with a cart that has buckets of all the different tools. I could give a list of I really like it's the Baco thin-jawed crescent wrench. And you'll have these users too. I understand in the machining world, well, oh God, you're using crescent wrenches. Wait, our users, if you have a set of wrenches at every desk, that's too much, right? This is what works for the users, and it works well. So I've got a cart that I'll just go around with in the morning and just replenish all the different stations. I don't try to say, where's that thing or whatever. I think that seeing what's natural. So when I did the tool layouts, I would put the wrenches and things that I most often would need for that thing. I'd put it down in the drawer. And then I'd just look at how I went to the tool, and I'd look at how I instinctively go to grab it and where I go to grab it. So then you put your finger, you cut out the finger things there. But I think a lot of this is just looking at what users are doing and trying to be realistic. So a biggest thing for the foam is the height of the tool, right? We're getting specific. We see that the user, we have 1-inch foam, but this Baco wrench is, I don't know, it's thin. So now the user has to reach down into the foam. Maybe they have finger holds, but it's too tight and they don't like putting it back, or it's open. And now when they put it back, it's crooked in the thing. So these things, it's like, we have to be like, okay, I get frustrated as a person. I need to like push that away, say, okay, what do we do?
Do you ever get feedback? You ever get feedback from the kids that say, yeah, this is really hard to deal with, or better, do you ever get feedback that says, this is awesome. Like, I know where to put things back and I don't have to like wonder.
Oh,
or is it thankless? Is it a thankless task?
At the end of the year, I mean, they'll fill out, anonymous feedbacks, and this semester I got a 5.5 out of 7, which is low. So I need to work on being more considerate, and those are filled with comments for us, feedback, and it's yep. You really got to look inside and be like, how can I, change as a person and grow, and so there's that. I think it's generally you're not being thanked for the good things that you're doing. I think that, or if they are, there's assuming, right? If you come up with a new system that helps people out, they're going to say, well, what you should have done additionally for this system is, I think it's maybe like having kids. I don't know.
Maybe. It's exactly
it's
like
working.
Having kids.
It's going forward. But for Unix's question there too, probably one of the most important things I did, because we do all the maintenance and we do all the little tiny fixes or improvements on our own. And so when I first got here, I ordered a drawer set for myself, and it's right by my desk, and I foamed it out for myself. I'll be working and stuff, and I'll think, I'm 3 days into some job. My mind is all over the place. Let me just put all my tools back in this drawer. So at least for myself, I think even when you're working alone, it's worth it, because it just makes you so much more efficient to know where our tools are going to be. And yeah, I don't know.
So we got 2 questions I want to hit, and then we're over time. I know we're over time, guys, but I want to get these 2, and then we'll probably wrap it up. I think we're going to take it I'll take it in this order. Greenwood AG says, how do you balance safety while allowing learning? I think we sort of touched on that, but is there anything else you want to add to the safety learning balance?
Yeah, safety. That's an interesting one. In the last couple years, I've had 3 incidents that make me learn these rules that I need to say as a disclaimer to the students is, never 2 people working on a machine together, right? It's when you have 2 people and then one person puts the piece in, but then they hesitate and they reach back in, and the other one's already starting to do their job. That's where we had a finger get pinched. Nothing in the machine shop, in the entire shop, should require more than a couple pounds of force. A grad student was in over the summer, and he pushed the high-low speed lever so hard that they broke a cast iron piece inside, and it slipped and smashed their knuckle.
Ooh.
So then it's like, wait, so there's that one, and then the third one. If something starts to drop, just let it. Somebody tried to catch something, and then they put their hand into a drill bit. So for safety, I think that there's a wall that instructors can hide behind in terms of safety, where it's like we want to get them on machines faster and doing these things, and then we have to not worry about damaging the machines. Yeah. I don't know.
In aviation, we had a saying which was, with respect to having multiple pilots in the cockpit, it was 1 + 1 = 0.75. It's like, yeah. Let's see. Shadow says, do the students have interest in watching machining videos before joining your class?
I think I love the students. They're amazing. They're not doing the things that we're thinking that they're doing. No, they don't have any interest in. Maybe they would, but I don't think so. I think if I sent something out, no. I think that the way, and this is just a difference in figuring out how they tick. Create an exciting project. Make that project only able to be done well if you do the theoretical things that you want engineers to learn. I think.
I'll point out that these students have a lot on their minds. There's a lot going on. And as much as we in this community want to talk about chip thinning, I think that they have a different goal. But so I think what you just said is pretty brilliant, which is make it so that they need to do a good, I'll just generalize it, do a good machining job to achieve their goal, and then they're going to have to learn how to do a good machining job. But I don't think you're gonna find 1 in 1,000 of these students that are as nerdy about machining as we are, and then that's fine. Then they join us, and they're another one of the nerds. Okay, let's see. Last chance. Any last minute questions, because we're going to wrap this up, guys. Only because the clock is yelling at me. Warren says, thanks, Dan. This was a great time. That's Warren up in Concord, New Hampshire. Thank you, Warren. Let's see. Widgetworks is typing something. Hey, Evils is now in Discord. Evils, you won, buddy. You won the McMaster car catalog. Evils was just telling me that he was on some other podcast, something, and he won a thing. Now and 5 days later, you just won another thing. Let's see. Widgetworks says, thanks from the Great White North. He's up in Manitoba. Alberta. Almost. Let's see. Anyway, so I think we're gonna wrap it up here, Dan. Thanks so much. Hope to have you back on. Maybe we can get you on at the same time as Adam Balog, and get some of the educators all in the same room. Pull the pin and run.
That'd be cool.
Yeah,
no, that'd be really cool.
It would be cool because it's an interesting. Hey, Widgetworks, I would never make that mistake twice, I promise. I get confused. Canadians confuse me. I'm sorry. I'm so sorry. We'd love to have you back, and next time I'm back down at MIT, we'll have to go to Toski's and do the thing. Carl, thank you, Carl. So let's say our goodbyes. Thanks again, Dan. Thanks to everybody in the Discord. Right now, we increased the population of the Discord. We've got Unix Carbide, Paul Morley, Warren Jones, Justin P., Carl Tauber, Widgetworks, Daniel F., Evils. You're late, but we forgive you. Tux Garage, Almost Machining, Josh, Bill Olney, Robert Simpson, Thomas Hardy, and Brian Rodney. I can't read the rest. Thanks for being here. Dan Gilbert, MIT, LMP, thank you for being here very much, buddy, and we look forward to seeing you again. Everybody, we'll see you guys next week for another PFG Live, and we remind you to get flat, stay flat, and keep all 10 digits. We'll see you later.